Now that we spent so much time on dummy projects and all those important basics, it's time for our first, a little bit bigger project. We're going to build this Monster Slayer game in this module. It's a little game where we got various options for fighting against a monster. We got a battle log where we can see what happened, for example, how much damage we dealt. And most importantly, in this game, we'll practice all those core basics we learned about throughout the last modules and lectures. We'll practice data binding, interpolation, vbind, event binding with vOn. We'll practice how to output lists of data with v-for. We'll have conditional content with vif, like this game over screen, and so much more. It's all in there, and therefore that's the game we're now going to explore in this module to really strengthen all that core knowledge we gained over the last module and to ensure that we're all on the same page and well prepared to venture deeper into Vue.js after this module. So let's get started. Attached to this lecture, you find this starting project, which is this index.html file with a basic skeleton for our application. No Vue logic is in there yet, it's really just HTML. You got a style CSS file with some basic styles we're going to use throughout this module, so throughout this app. And you got an empty app.js file, because we're going to write all the Vue logic together step by step. Now, as I said in the last lecture, we're going to build a simple Monster Slayer game where we have a monster health and our health. We got various options for attacking, launching a special attack, healing ourselves, or surrendering, and we want to implement all of that with Vue so that we have this browser-based game here, which we can fully control with JavaScript, but of course not with just JavaScript, but instead with Vue and JavaScript. And for that, obviously, we're going to start by controlling this with Vue. So by taking over control over some HTML code with Vue so that we can use Vue features here. And you might notice I already prepared this div with an ID game here, and well, that looks very tempting, and indeed this is the div we're going to control with Vue, because it turns out that inside of that div we got the entire game HTML code. The header is outside of the div, but the header is nothing we need to control with Vue. We're not going to use any Vue features in there. Therefore, in app.js, like we did many times before, we can create a Vue app by calling Vue create app, and we can store this in a constant and then mount our app here to this game div. So to this div with an ID game, and therefore we use the ID game selector here. So now we got a Vue app connected to this div, and now the question is, with which part do we want to start? There certainly is not just one possible route you could take. There are multiple routes, like always in programming, but I would suggest that we simply start with the attack button. So we basically implement features top to bottom. So the attack button here, when pressed, should of course reduce the monster's health, but at the same time the monster should then also strike back so that our health is also reduced. And we probably don't want to use a single hard-coded value by which we reduce healths, but we want to use some randomness so that our game isn't too predictable. And therefore in app.js, I'm going to start by managing some data. And you already saw it by now in the last lectures and modules. Data, of course, is a core concept, a core thing in Vue apps, because pretty much any app you're going to build needs some data. No matter what you're managing in there, but you're going to need some data. Think of data as the variables you need in your regular JavaScript script codes, and it makes a lot of sense that we need data. For example, here in this game, which kind of data do we need to manage here to make anything really work? Well, how about the healths of the player and the monster? We need to manage that data, we need to manage that health data because we're going to change it. And changes in the health, of course, should later be reflected back on the UI so that these health bars are reduced. So therefore we need data. We need this data option in our view app configuration object. And as you learned in this data method, which it should be, we return the object that holds our actual data. And here I, as I just explained, have two main data points, and that would be the player health. And let's say we start at a value of 100 here, though of course you can pick any values you want. And we'll need a monster health. Now we could say the monster has more or less health, but I'm also going to set the monster health to 100. So now we got these two health values, which allow us to, well, manage the health of our two game participants. But the health alone is not enough. Of course, we also need ways of changing the health, for example, when an attack is launched. So that screams for methods, because methods are essentially the actions we support in our view application. For example, when the attack button is clicked, we want to trigger a method that reduces the monster health. And therefore I'm going to name that method attack monster, because that's what we're doing. We're attacking the monster. Now what should we do inside of this method then? What should happen inside of attack monster? Well, we want to calculate the damage we're dealing, and we then want to reduce the monster health by that damage. And as I said before, I want to use a random value here. You could of course always deduct the same amount from the monster health, but your game would be pretty predictable then. So to calculate a random value, we can use the math random function, which gives us a random number between 0 and 1. Now I don't want a value between 0 and 1. Instead, since we're working with a health of 100, we probably want a higher number. So for example, we could say that we want to get a random number between a minimum and a maximum value. Let's say between 5 and 12. We want to deal at least 5 points of damage, but no more than 12 points of damage. And the formula for calculating this is to multiply math random with the difference of max, which is 12 as I just explained, minus the min value, which should be 5 for example. And then we take the floor of that to round it down so that we don't have a number with a decimal place, but we have an integer number instead, and we add the minimum again. This is a formula for calculating a random number between 5 and 12. So this will give me my attack value, let's say, by which I want to reduce the monster health. So therefore, here, I want to reach out to this monster health, and I explained that we can access all data properties in your methods through the this keyword, because view will merge all your data properties in this object into a global behind the scenes managed object, and that's why we can use this here in a method and get access to this monster health. And we want access to monster health so that we can set monster health equal to this monster health minus the attack value we just derived. We can also write this in a bit of a shorter way. We can use a JavaScript shortcut here, a shorthand notation, and use minus equal attack value. That's exactly doing the same thing. With that, we're reducing the monster health by the attack value we derived here. Now, that's one part of the equation. We want to be able to attack the monster. But of course, the monster should also be able to attack us as a player. And let's say whenever we attacked the monster, as a consequence thereafter, the monster should attack back. So we can add a second method, a second action to our game, so to say, which is attack player. So that is the monster attacking us as a player. And here we want to do essentially the same. We want to get an attack value calculated randomly But let's say the monster actually hits a bit harder, so the max damage is 15, and the min damage, let's say, is 8 instead of 5, so that by just spamming attack all the time, we probably won't win, because the monster hits us harder. And then we take this calculated attack value and deduct it from the player health. Like this. Now, since I have the same formula for calculating a random number, I will actually outsource this into a separate function. And here I'll use a regular JavaScript function and not a view method, because this will be a function which I only call from inside my JavaScript code, which will not use any view-controlled data properties or anything like that, and which will not be called from inside our template, so from inside our HTML code. And if all of that is the case, if you don't need access to view-controlled properties, if you're not calling the function from inside HTML, and you only use it from inside the JavaScript code, then you can write a regular JavaScript function, and I'll name it getRandomValue, and I want to get a min and a max boundary here, and then just grab that formula, cut it, and return it here, and replace 12 with max and 5 with min. And the advantage of this is that we can now simply call getRandomValue here and pass in 5 and 12, and do the same down there and pass in 8 and 15. And with that we save some code and we simply outsource this into a separate function. Okay. So with that, we got our two actions. One thing is missing here in those methods, and then of course we also need to connect this to the HTML code. But the missing thing here, of course, is that attack player should be triggered whenever we attacked the monster. So here, after attack monster, I'll reach out to attack player and call this method here. And that's something we haven't done thus far in the previous modules. But just as we can access data properties through the this keyword, we can also access methods through the this keyword inside of the view instance config object here. And the reason for that is the same as with the data properties. I mentioned that this data would be merged into a behind-the-scenes managed global object, and it's the same for methods and for computed properties. All of that is getting merged into that behind-the-scenes controlled global object. And therefore, just as we can access data properties through the this keyword inside of methods, we can also access other methods in there and call them. So we can call attack player here from inside attack monster to make sure that this method executes right after this method executed. And with that, we're done with the JavaScript code for now. But of course, we also need to connect this to our HTML content now. We need to make sure that in our HTML code, we now also trigger attack monster when the attack button is clicked, and that we update those health bars. So let's work on that next. Of course, feel free to try this on your own first, before we then continue together in the next lecture. So let's do this together now. Let's make sure attack monster is triggered when the attack button is clicked. And for that, of course, we need to go to the index.html file. Here we have the attack button, and we simply want to add a click listener to it. We can do this with v-on-click, or as you learned, we can use the shorthand with just @click. And that's the style I'm going to use throughout the course, so I'm using it here as well. Now here, as a value, we want to make sure that attack monster gets executed, and therefore we can call attack monster like this, or as you learned, alternatively, we just point at it, we just provide the name of the to be executed function to view here, and view will execute attack monster for us when a click occurs. Both is supported by view. I'm going to use this point at the function approach. So now attack monster should be executed when we click the attack button. But in order to see something, I also want to make sure that those health bars are updated when the player and monster healths change. And how could we now achieve this? Well, this div here, these two divs, the health bar value divs, in the end, these are the divs that control by how much the health bars are filled. So if we change their width, we'll reduce the health bar on the screen. And here I will actually use inline styles with the style attribute to set that width and override any width set through a class. This is one of the scenarios where such an inline style approach makes sense, because we want to be able to set the width to any value, so predefining CSS classes with all possible widths we might need is pretty cumbersome and almost impossible. Therefore here, I want to set the inline style, but of course I want to set it dynamically. And we can do this with vbind or just the shorthand of :style. And then you learned that you can pass an object here to your style binding. And in that object, you can define which CSS property you want to change and then give that property a potentially dynamic value. And here I want to change the width property of this div and set it to a value which indeed will be dynamic. I want to set it basically to my player or to my monster health, depending on which health bar I'm working on. Here, this is the first health bar, which is the monster's health bar. So here, I want to use the monster health. So this data property. And as you learned throughout the last lectures and modules, here in your HTML code, in the template of your Vue app, so to say, it's not this monster health, it's not data monster health, it's just monster health. You have direct access to all your data properties and to all your methods without using this or anything like that. Now, the monster health will be a value between 0 and 100, at least once we're done. At the moment, it could also become negative, but we'll prevent this soon. But it will definitely be not higher than 100. And that's pretty good. That means we can use a percentage width here, where initially it's 100% and it can go down to 0%. So in the end, we set this to monster health plus percentage sign as a string, because width is a CSS property and it wants a value like 10 pixels, 1 rem, or 50% or anything like that. So you need to add a unit. Hence, the number alone is not enough. Instead, we combine the number with a string to turn it overall in a string, which is what width wants here if we set it through JavaScript. And that string contains the unit of this value, so that we set this to 100%, to 80%, and so on. And of course, we don't just want to do that here on the monster health, but also here on the second div on the player health bar. But of course, here we therefore refer to player health. And now if we save all files and reload here, if we press attack, you see the health bars become lower and lower. They are reduced, and that proves that both our data as well as methods logic here works, and that our dynamic style bindings also work. Now, there's one thing I want to improve. It's optional, but something I would recommend. As I also mentioned already a couple of times throughout this course, you shouldn't put too much logic into your HTML code. You want to keep that HTML code relatively lean. And therefore, I will actually cut this here and add computed properties. As a side note, this is a nice practice. So here I'll add computed properties with the computed option in our Vue instance config object next to data and methods, though the exact position does not matter. You could add it after methods or before it, doesn't matter. And in here, I'll have my monster bar styles, where I want to return this object I just cut. But here, of course, we should now use this monster health, since we're now having code inside of our Vue instance object. And we'll need player bar styles, where I want to return this object here, which I had on the player health bar. So return this here, this JavaScript object. Of course, reference this player health here, as just explained. And now we can use these two computed properties here to set our styles dynamically. So here it's the monster bar styles, and down there on the second bar, it's the player bar styles. Now let me reformat that and save that. And if I reload, it still works, but now we got the logic out of the HTML code, and we're also using computed properties. So that is our first important step. The attack function works. Now let's make sure the special attack function also works. Now that the attack button and the attack action is working, let's implement the next action we want to support in this game. And that is the special attack action, and therefore the special attack button that should work. The idea here is relatively simple. I want to do the same as in attack monster, but we should deal more damage. On the other hand, and to not make this too powerful, the special attack should therefore not be available all the time, but only every 3 rounds. So let's start by adding this method though. I'll name it special attack monster. And in here, I want to calculate an attack value, but let's say between 10 and 25 damage points. So we have the potential to do quite a lot of damage. Of course, just as before, we then reach out to the monster health and deduct the attack value from it. And also just as before, the monster should still attack us back thereafter. It does not just attack back if we launched a normal attack, it also attacks back if we use a special attack. So here we call attack player thereafter to make sure that we as a player are attacked after we launched a special attack. Now with that, we can connect this special attack button here, again by adding a click listener, and then by pointing at the special attack monster method we just added. And if we save that and save the JavaScript file and reload, if I click special attack, I'm doing a lot of damage to the monster, as you can tell by its quickly shrinking monster health bar. But the problem is that right now we can spam this attack. So winning would not be too hard because we can press the same button over and over again. And therefore I want to restrict this powerful attack. It should only be available every 3 rounds. And when it's not available, this button therefore should be disabled. So how could we implement that? How could we make sure that this is the way it works? Well, we could keep track of the number of rounds the game is already lasting. For that, we can add a new data property because we got a new piece of data we want to change and update and be aware of. And I'll name this current round. I'll add it here to the data property and not add it as a regular JavaScript variable, for example, because we'll need access to it from inside the Vue instance, and Vue needs to be aware of when it changes. And that is all the case if something is a data property in the Vue app. So now we got the current round, we start at 0, and I want to increment that round, of course, whenever we do anything. So whenever we attack and so on. Whenever that happens, the round should change. So therefore, for example, when we attack the monster, I'll set this current round ++ to increment it by 1. When the monster attacks us, I'll not do it because that will still be the same round, right? The monster attacks us whenever we did something, so we don't need to change the round again when that happens. But we need to change it when we launch a special attack, of course. So now we got this current round. How can we now use it to control the special attack button? Well, we can go back to index.html and disable the button if the current round is not divisible by 3. That makes sure that we can only use it every 3 rounds. To achieve this, we can set the disabled attribute of a button, but of course not like that, but instead to a dynamic value, and we can do that on attributes as you learned with vbind, or again, this shorthand of just colon disabled. And I want to set this to true or false. And true or false should be derived based on the current round. So here we can access current round. So this current round data property we added. And use the modulus operator, which we have in JavaScript, to divide it by 3 and find out what the remainder of this division is. And we know if the remainder is not 0, then this was not divisible by 3, and therefore we know we're certainly not in the 3rd or 6th or 9th round. And we only want to enable the button in those rounds. So we'll disable it if the division of 3 does not leave a remainder of 0. If we saved it and reload, the special attack is available, but once I clicked it, you see it's become gray. And now I need to do 2 more normal attacks before it's enabled again. So this is now working the way it should. But as so often, I don't necessarily want to have that logic in my HTML code, and therefore I'll cut it here, go back to app.js, and add a new computed property, which we could name may use special attack. And in here we simply return this calculation, now using the this keyword though, since we're in the view instance. And with that we can use the may use special attack computed property here, just like that, to make sure that the button is disabled when it should be disabled. So that's working now, and with that we ensure that we only have access to the special attack every 3 rounds. And that's the special attack functionality implemented. So we can launch a special attack every 3 rounds, and we're already using some nice view features that make building such a game very, very easy. Now let's move on to the next button, to the heal button. Maybe we as a player took too much damage and we want to heal ourselves. So we should implement a functionality for that as well. So in the methods of my Vue app, I'm going to add a heal player method, because the heal functionality, the heal button, of course should heal the player, not the monster. For that, I'll calculate a heal value, and we can use the same getRandomValue function to get a random value between 2 boundaries. And it's up to you which values you want to use here. Since the monster hits us between 8 and 15, I want to get a heal value of, let's say, 8 and 20. So between 8 and 20. And now, of course, we'll just reach out to the player health and simply add that calculated heal value. But we should be careful here. Always adding this heal value like this would introduce a bug in our game, because we could heal ourselves above 100 health. We start with 100 health and we shouldn't be able to heal ourselves for more than that. So to prevent that this happens, we can add a if check here in heal player and check if our player health plus the calculated heal value would exceed 100. And if that's the case, if we would heal ourselves above 100, then I instead want to set the player health to 100, so that we can't go higher than that. And only in the else case, if our current health plus the calculated heal value does not exceed 100, only then I want to add the full heal value to the player health, simply to ensure that we can't go above 100. So with that, we got the heal player method. Now we can connect it to the button by adding a click listener, as we did many times before, and by calling heal player, just like that. And if we now save that and reload, if I press heal initially, nothing happens, but if I launch a special attack, this works, I can attack, and now let's heal ourselves, that worked, heal ourselves, that worked, so that's looking good. But we're not fully done. For one, healing ourselves should also count as a round in the game. So of course, here, I also want to increment the current round. In addition, the monster should attack us thereafter, because just because we heal ourselves does not mean that the monster does nothing. So once we're done healing ourselves, the monster will attack the player, and we do that by calling the attack player function. And now with that, if I reload, you see if I heal myself initially, my health still goes down, because healing myself initially makes no sense. I already have a health of 100, so we heal by nothing, but the monster attacks us thereafter, and hence we take damage. But of course we can still heal ourselves thereafter, and eventually, well, try to win that game. Yeah, like that. So that should work, but of course we're still not done, with the game at least, because we now have all those actions here, and the health bars change appropriately, but how does the game end? We want to ensure that either the monster or the player wins, or for the unlikely scenario that we both go below 0 health, that we have a draw. And that could happen, by the way. Since we attack and the monster always attacks back, we could launch an attack that takes the monster below 0, and then with its last blow, the monster also takes us below 0 health. So a draw would be possible. Well, let's work on those win and lose conditions next. Of course, feel free to try implementing this on your own first, before we then implement it together, because that, of course, is a great practice. So how do we now check who won and who lost? Well, for that, we need to basically check the health values, the player and the monster health. That is what matters to us here. And hence, we could add if checks here after we attacked the player. So after both the monster and the player got attacked, here we could check if this player health is smaller than 0, in which case the player lost. And we could check if maybe also the monster health is below 0, and so on. But we would have to repeat this check, we would have to repeat this check in the special attack monster function and also in the heal player function, because maybe we healed ourselves, but the monster still dealt too much damage and we still died. So repeating the same code in all those places, that's not what I want to do, because repeating code is never good. If we ever decide to change something, we need to change it in a lot of different places, and therefore we want to avoid that. Instead, with View, we have a nicer way of keeping track of something and then doing something in reaction to that. We could add a watcher. So I'm going to add watchers here by adding the watch option to the configuration object. And here I want to watch two properties, the player health and the monster health. So we add a watcher for the player health property. And as you learned, this name is now not up to you. Instead, that has to be the name of a property you want to watch. And here I want to watch this player health property. And hence I'll also add a second watcher where I watch the monster health, like this. You also learned that we get the values then of those watched values whenever the watcher triggers. And therefore let's now start in the player health watcher. There we need a regular if check where we check if the value, so the player health, is smaller or equal than 0, and if, let's say, the monster health also is smaller or equal than 0. In that case, we would have a draw, because both participants are below 0. Now another case would be if just the value is smaller or equal than 0. So the first condition is not met, but the value, so the player health, is below 0 or equal to 0. Then we know the player lost. We don't need to check the monster health being smaller than 0 here, because we're going to do this in the monster health watcher. There, indeed, I want to check if the value, so now the monster health, is smaller or equal than 0, and if the player health is smaller or equal than 0. In this case, as mentioned, we have a draw. Or else if just the value of the monster is smaller than 0, then the monster lost. Now, of course, I am aware that if we take the monster below 0 and it then hits us and takes us below 0, both watchers fire because both healths changed, and therefore these if checks run twice and we'll find out that we have a draw twice. This won't be a problem, however, because you will see what we do with this information. We're just going to show something on the screen and it will only show up once there. So finding out that we have a draw twice will not be a problem. What do we want to do if we have a draw then, or when the player lost, or the monster lost? Well, we probably should display some message on the screen. And for that, let's go to the index.html file. And here, above the controls, but below the health bar sections, I'll add a new section now. Give that section a class of container, which will just give it some default styling. And now inside of that section, I want to say game over, and then either say you lost, or you won, or it's a draw, and also present a button to start a new game. And that screams for what? For VIF, because now we have conditional content. First of all, this entire container with the game over message should only be shown if the game really is over. So if we either have a winner or a draw. And then the message below that, something like you lost in a h3 tag, or you won, or it's a draw, those h3 tags should also be shown conditionally depending on who won or who lost. And therefore we need to not only check those values, but also change something which we can then reflect in the HTML code. And that again screams for a data property. Here we could store the winner and initially set this to null, because initially when the game starts we have no winner, of course. But then here, if we have a draw, I want to set this winner equal to draw, let's say. So to a string that says draw. If the player lost, I want to set this winner equal to monster, because the player lost, the monster won. Here it's this winner, which is a draw again. And if the monster lost, this winner, of course, is equal to the player. So now we have the winner data property, which is either null, or if it's not null, holds a string of draw, monster, or player. And we can use that in conjunction with VIF to conditionally show this entire game over container, but then also the different messages. The entire container can be shown with VIF if indeed winner is truthy. By default, at the beginning, it's null, and that is treated as a falsy value in JavaScript. So if I set VIF winner and winner is null, this section will not show up because null is interpreted as false. If it is a string like draw or monster or player, the concrete value does not matter, then this is truthy and therefore this section does show up. Now inside of the section we also need VIF, here on the h3 elements. I want to show you lost if winner is equal to monster. Else if, and for that we can use the velse if directive, I want to show the second h3 tag if winner is equal to player, because if the player won, I want to show you won. And last but not least, with we else, we can show it's a draw. We could also use we else if to check if winner is equal to draw, but since we know that we only have those three options, I can also just use we else. With that added, if we now reload, you see initially we have nothing here. By the way, when the game loads, you briefly see that other content show up until the view framework is downloaded. That is something we'll also tackle later in the course. Later we'll have a different setup where this initial flickering is not visible, just as a side note. But here, that is our starting setup now. And now let's try to end the game. And let's see who's going to win. Okay, looks like we lost. The health bars are not reflecting this because they basically don't go into the negative, they don't reach 0, but we see the you lost message. Now let's reload and let's try to win. So for that, we need to use the special attack and also heal ourselves a little bit here. Special attack, attack, heal ourselves maybe, special attack, and we won. And let's see if we can achieve a draw here. I'm not sure. Well, I won again. Here it is, I was able to achieve a draw as well. So this seems to work, we're showing the proper message here. Now let's make sure we also do restart the game thereafter if we do have such a draw. And let's maybe also update the health bar correctly to really have an empty health bar if the game is over. I want to start with the empty health bars, and for that we have our computed properties with the bar styles, right? Well, we could change those a little bit and tweak them to make sure that we set our bar widths to exactly 0% if the game is over. That should be fairly easy to do here, because we can check if this monster health, in the monster bar styles, if monster health is smaller than 0. If that's the case, I want to return an object where the width is set to 0%, so that we set it exactly to 0. A negative value can't be displayed, so we need to set it to exactly 0. And only otherwise I return the dynamically calculated health. And we can do the same here, check the player health, the player health. If it's smaller than 0, then I want to return width of 0% and otherwise return the actual value. With that, if I reload and I quickly try to end the game, you see now my health bar is empty now that I lost. And if I try to win here real quick, you see now the monster health is 0. So that seems to work. Now for restarting the game. We could add a button in our game over box below the H3 tags. A simple button like this, where we say start new game. Now this button should do what the name implies. It should start a new game when clicked. For that, of course, we need a method, because we need a new action which we can trigger from inside our HTML code. Hence, I'll add a new method here. The position of the method does not matter, by the way. You can add it at the end, in between, or at the beginning. And I'll just add it here because start game sounds like it should be at the beginning. And in here, I now essentially want to reset all those parameters. So player health, monster health, current round, and winner. This should all be reset when we start a new game. So therefore, we can set the player health back to 100, set the monster health back to 100, set the winner back to null because we have no winner, and of course also set the current round back to 0 because we start a new game again. And now it's start game that should be triggered when this button here is clicked. So we simply add a click listener as we did it many times before and point at start game. And if we now save that and reload, let's give it a try. Let's try to end this game here and see who wins. It's a draw, but we have start new game. And if I click this, you see the health bar is updated and a new game begins. So this is working here. Let's now also see if we can lose. Yes, and this all works. So now we got this start new game functionality as well. We got the game working therefore, but the surrender button is missing when we want to, well, surrender, and the battle log is missing. A log which I want to have at the bottom of the page, which simply shows every action that happened. So every damage dealt, every health point healed, that should show up here. And I'll implement the surrender button right away in this lecture already, because it will be super easy. If we add a new surrender method, which we of course need to be able to do anything when that button is pressed, I want to set the winner equal to monster, because if the player surrenders, the monster won. Alternatively, we could also set the player health to a negative value, but I don't want to do that here. I don't want to kill the player with, well, by setting the health to 0 or something like that. The player simply surrenders. So we just set the winner to monster and we're good. And now we can go back to index.html, and on that surrender button, we bind it with a click listener to the newly added surrender method, just like that. If we now save that and reload, if I click surrender, I can start a new game. One thing, however, is not ideal. Even if I surrender, I can still press attack and the health bar still update. So we might want to disable all those game action buttons if the game is over, or remove the controls entirely if the game is over. And that's actually something I will do here to finish this lecture. We do show this game over container if we do have a winner with VIF. Now this section is a direct neighbor of this section. So here we could make sure that this only shows up if we don't have a winner with not winner, so if winner is falsy, or since it is a direct neighbor, by using VElse, so that we only have those game controls if we don't have a winner yet. And if we do have a winner, we'll not have the game controls. So if I save that again and I surrender, now the game controls are gone and I have to start a new game to bring them back. And the same happens if we lose the game naturally. The game controls are gone and we have to start a new game. And with that, I think the core game functionality is finished now, and next we can work on that battle log. Again, as always, feel free to implement something on your own there. We'll do it together in the next lecture. So let's move on to the battle log. And there are certainly many ways of implementing such a log. I want to have a log where we can add messages that basically keep track of which action occurred and who started this action and which value was connected to this action. For example, how much damage was dealt. For that, we should go back to app.js and add a new method here, which could be called addLogMessage, because that is what we're going to do. This method should take 3 parameters. It should take the information who did something. So I'm going to name it who. Then I want to know what happened. Did we attack? Did we heal? So I'm going to add a what here. And I need to know the value. How much damage was dealt? How much did we heal for? So these are the 3 parameters we need here. Who, what, and value. And with this information, I want to add a new log message to a growing list of log messages, which then can be output here in this battle log on the screen. Hence, what do we need? A data property, an array of log messages, which can change and which view tracks to be aware of changes so that it updates the UI when it changed. So therefore here, I'm going to add a log messages array, which is empty initially, and whilst we're at it, we can also already reset it to an empty array when we start a new game. So set log messages back to an empty array here. But now that we got log messages, in add log message, I want to add a new log message to this array whenever this method is called. And I want to add it at the beginning of the array so that the latest message is always right on top. So it's the first one in the array. And we can do this by reaching out to log messages and using unshift. Unshift is basically like push, but where push adds something at the end of the array, unshift adds something at the beginning of the array. And now it's up to you how a log message should look like. Thus far in the course, in the other lectures and modules, when we worked with lists and arrays and v-for, we always had arrays full of strings, full of text. Here, since we have 3 pieces of information that matter, I will actually add an object to this array. So a log message is an object. And you will see how we can output this on the screen in just a second. So here I will now add different pieces of information to this object, the who, what, and value to be precise. And I'll name the key action by who, action type what, and action value, the value we got. So we add an object to our log messages which has 3 keys, action by, action type, and action value, so that we know who did the action, which kind of action it was, and what the value of the action was. That's how we add log messages. And now a new log message should be added when we, for example, attack the monster. So here in attack monster, before the monster attacks us, I want to call add log message, so this newly added method, and set the who to player, because the player attacked the monster, want to set the action to attack, and pass in the attack value, like this. Now when the monster attacks us, here in attack player, I also want to add a log message, but now it's the monster who attacked us for this given attack value, which we derive here as well. Of course, we do the same for the special attack. Here the player attacks the monster. We could also name this special attack, but that's really up to you how you want to handle those different types later. I will not differentiate between special attack and regular attack, so I will just name it attack here as well. If you would want to add such a differentiation, you could use a different identifier here, but I'll stick to attack. And last but not least, for healing here, the player heals himself for the heal value. So that is the log message I want to add here. So now we got these different log messages being added. With that, our log messages array will grow. And now the question is how we output those messages. In index.html, we got this unordered list here in our battle log. And this unordered list should render a bunch of list items. As I mentioned before, you don't need to use a list item to use v-for. v-for can be used on any element. But since we're outputting lists of data and we want to write semantically correct code, often you will use v-for on list items, because that is the semantically correct HTML element, well, for list items. That's just a side note. The more important thing, of course, here is that we use v-for though. A nice view directive we learned about, which can help us with outputting list content. It allows us to repeat this list item element and create it as often as needed to have one list item HTML element on the screen per item in our log messages array. So therefore here we need to refer to log messages and go through it with the in keyword and then get access to every single log message, which we now can use on and inside of this repeated list item. And now here, the content we want to output, of course, is fully up to you. We could use interpolation here to output the action by field, which is one of the 3 fields we add as a log message, which basically indicates who did something. Then we could add a dash and a new piece of interpolation here to output log message action type so that we know what happened, and then another dash and another piece of interpolation here to output our action value. That's something we could do. With that, we would output who did something, what happened, and which value was associated. And if we save that and reload, indeed you will see if I click attack here, we have these two log messages where we see that the player attacked for 6 and thereafter the monster attacked for 8. And that's a nice start, but actually I prepared some styles to output this in a nicer way. So let's actually use those. And therefore I'm going to get rid of that and instead add a span here, a span element, which actually should hold the initiator of the action. So this action by field. So here I want to access log message and check if action by is equal to player, in which case I want to print player here with a capital P. Otherwise it'll be the monster, so I'll then output that. So a little ternary expression here. I also want to have a second span thereafter, which holds the type of action that happened. And here we either dealt damage or we healed ourselves. So with vif, I'm going to check if log message action type is equal to heal, in which case here I want to say heals himself, so that we say something like player heals himself for, and then of course the amount of healing done, which I'll wrap in another span simply so that I can later add some styling to highlight the value. And into this second span here I'll add the log message action value, which is the amount for which we healed here. And I'll give this span here a CSS class of log dash dash heal, which is one of the prepared CSS classes here to simply color the amount by which we healed green. That's the only reason why I have this extra span here, so that I can add an extra CSS class just to this heal value text. Now this was one option. I need another span next to this general heals himself span, and that is for the scenario that we actually dealt damage, that we did not heal ourselves. Here we can use VLs because dealing damage is the only other option we have in this game. And therefore here I'll say attacks, so that we say something like player attacks, and deals. And now again output the damage in a span so that we can add an extra CSS class. In this case the log dash dash damage class, which is a prepared CSS class to give it a red color, and output the damage value again in that special span so that we take advantage of this highlighting of this special CSS style. So here we have log message.action value again. So this is now how we could structure this. I also want to add a CSS class here to this first class to highlight who did something. And for that, I'll dynamically add a class here because I want to add different classes depending on whether we have the player or the monster doing something here. So I'll add this object syntax here and add a class of log dash dash player, which is another prepared class here, this one, if action by is the player, and add log dash dash monster if the action was started by the monster. You need single quotes around those keys here, by the way, since we're in a JavaScript object here, and dashes in property names are not allowed without wrapping the whole property name into quotes. With quotes, though, they are allowed. So that's why you need single quotes around your property names here. And the values of these properties here, as you learned, need to be values that indicate whether or not those classes should be added to that span. So you need true or false here in the end. And therefore we can simply check if log message action by is equal to player here, If that is true, I want to add the log player class. If that's false, I don't want to add it. And for adding log monster, I want to check if log message action by is equal to monster. And of course, only one of the two will be true at a given time. And that's my logic here. Now, this is quite long, but outsourcing this into a computed property would actually not really be possible because this does not depend on some general data property, but on a concrete value we get for this exact list item which is being rendered. So if you would want to outsource this into JavaScript code, you would indeed need to use a method to which you pass log message action by, for example, because that is not a single value managed application wide, but that depends on which list item is being rendered. That's just a side note. With that, however, if we save that and reload, if we now attack, we see something like monster attacks and deals 12, player attacks and deals 6. If we heal, we see player heals himself for 9, and thereafter the monster attacked us for 13, so that didn't help too much. This now looks better, and so on. So this all seems to work. Now we got a log, and if the game is over, we can inspect the whole log. If we start a new game, it's of course reset as it should be, because in start game, we set the log messages to an empty array again. And that is the finished game here. That actually is a nice first project, which shows all the core features we learned about, like interpolation, vbind, von, different events, methods, computed, watch, vif, v4. It's all in here, and therefore I hope that this project helps you get a better understanding of Vue, the different pieces that make up Vue, and how they all work together. Now we're really well prepared to dive deeper into Vue.